Okay, fourth graders, today we are once again combining two lessons because they're basically the same thing. One just has more digits than the other, and I know you guys are ready to take it all on at once. So today we're going to combine lessons 9 and 10 from Module 3. And at the end of today's math lesson, you'll be able to comfortably use the standard algorithm, which is what we call the quote-unquote normal way of multiplying numbers. Okay? It's very closely related to what we were doing yesterday with the partial products method. Okay? But first, let's solve the problem of the day. We are going to review what we learned yesterday by multiplying 6 copies of 162. You'll recall that yesterday we learned two methods. We used a place value chart and we used the partial products method. Today we're going to add on by talking about the standard algorithm. But let's first start by reviewing what we learned yesterday. So if I want to use the partial products method, I can set it up by writing 162 times 6. Yes? Okay, now, the first part is I'm going to tackle the ones place, right? So I'm going to make 6 copies of 2 ones. On the place value chart, I'm going to start with 2 ones, and then I'll make 6 copies of it. 5, 6, which would give me a total of how many ones? 12 ones. We can go ahead and record that. Okay. Then my next place value position is the tens. How many tens do we have? 6. So I'm going to start with 6 tens. 1, 2, 3, 4, 5, 6. And I have to make 6 copies of that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How many dots now do I have in the tens position? 36. 36 tens. That's equal to 360, right? Because I know that 30 of those tens could be regrouped as 300s. So 300, 6 tens, and 0 ones. Our last one, of course, is 100. We have to make 6 copies of 100 as well. So I start with 100, and I'm going to make 6 copies. 1, 2, 3, 4, 5, 6, which gives me a total of 6 dots in the hundreds column. How do I write that as in standard form, as a partial product? Evan? 600. Okay. So now I have my place value chart is done. I have 6 hundreds, 36 tens, and 12 ones. If I were to regroup that, could I? Yes, I totally could. Because I can just bundle up 10 of them, right? I could bundle up 10 of these ones, and they would become 110. So now how many tens do I have altogether? 37. But then 30 of them would be regrouped to become 100. So how many hundreds do I have altogether? 7. Okay. How many tens do I have altogether? I had 37. I regrouped 30 of them. How many tens do I have? Everyone? 7, right? And how many ones do I have? 2. Okay. So I made a careless mistake. I regrouped 30. But I only added 100. I should have added 300s. For a total of how many hundreds? 900, thank you. Because 6 plus 3 is 9. Good. So if I add it up over here with my partial products method, I get the same number, 972. Yes? Good. So now the new part we're adding on today is called the standard algorithm. The standard algorithm is just what we call the basic equation for how we do something. So the standard algorithm for multiplication, we always set it up in the same way as our partial products way. We write the 2 factors on top of each other, and we don't really care too much, to be honest with you, about place value. We don't need to line up the ones with the ones, the tens with the tens. We want everything to line up on the right-hand side. Does that make sense? Then we just multiply. We think 6 times 2, we think one place value position at a time. So just like, it's basically the same as what we were doing with our partial products method. We're going to think about these 3 products, partial products, but we're going to combine them. Let me show you what I mean. We think to ourselves, 6 times 2 is 12. But I know that 10 of those can be regrouped. So I'm going to put a 1 up here because I'm recording the 2 from my 12, but I'm regrouping the 10 to become 1 more 10. Yes? Then I think to myself, 6 times 6 is 36. But I had an extra 10. So what's 36 tens plus 1 more 10? 37 tens. So I'm going to write that 7 here. And I'm going to regroup those 3 extra tens to become 300s. Does that make sense? I want you to notice that I'm writing it up here. My regrouping, I'm writing it above, so I don't get confused with what my actual product is, okay? And I think 6 copies of 100 is how many hundreds? 6 hundreds, but I had 3 extra hundreds, so altogether how many hundreds do I have? 9. So you can see that the standard algorithm is the same as the partial products. We're thinking about those 3 different partial products, but we're doing the regrouping at the same time. See how that works? Okay, good. For this problem, when I make 6 copies of 9 ones, how many ones do I end up with? Everyone? 54, thank you. Oops, let me make that neater. 54. Now, when we do that, how many could I regroup? 50 of them, right? How many would be left? 4. So I could really regroup all 50 of these ones, and I know they become how many tens? 5 tens. Okay, I'm just going to write that down. Okay, let's move on to our next place value position, which is the tens. How many tens do I have? 1. And I have to make how many copies of it? Okay, 1, 2, 3, 4, 5, 6. When I do that, how many tens do I have? 6 tens. But I had 5 originally. So what's 5 plus 6? 11, right? I'm actually going to rewrite these 5. I'm going to draw the dots. Remember how these were regrouped from the ones? 1, 2, 3, 4, 5. So how many do I have altogether? 11, right? But what can I do with those 11? Regroup them. Leaving how many tens? Yeah. And these can be regrouped to become 100. Okay, let's not forget our partial products way. We did 6 copies of 110, which is how many tens? 6 tens. So that's 60. Okay, do you guys see that? Good. Next we have 300s. So I'm going to write 300s. But I have to make how many copies of it? 6. 1, 2, 3, 4, 5, 6 copies. So now, by the way, how many hundreds do I have? What's 6 times 3? 1800s. How do I write 1800s? 1,800. Let's record that partial product. But let's think about regrouping. All together right now in my hundreds column, how many do I have? I have 18 plus 1, which is 19. Do I have more than 10? Yeah, I do. So if I count out 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, they can be regrouped to become 1,000. So how many thousands do I have altogether? 1. How many hundreds do I have altogether? 9. How many tens do I have altogether left? 1. How many ones do I have left? Okay, so I have 1, 9, 1, 4. Let's add up our partial products. If I start with my ones, how many ones do I have? 4. Because, remember, and there they are right here, because I regrouped the rest. Do you guys remember that? Oh, to be over here. Do you see how the 5, watch carefully up here. Do you see how the 5, the 50 ones that I regrouped is right here. It's already in the tens place. See that? Okay. And then the 6 tens are right here. When I add those up, I have 11, and I had to regroup it. Do you guys see how I had to regroup these 10 to become 100, which is what I'm just doing. See that? And then 1 plus 8 is 9, because 1 plus 8 is 9. I drew too many there. Nice. Okay, but then, and then it regrouped to become 1,000. Do you guys see that? Okay, so I want you to keep this regrouping in mind as we tackle the standard algorithm next. So I had to go on to a new slide due to technical difficulties, but I want you to write this near where you wrote your partial products way so you can see how it relates. We're going to use the standard algorithm now. So we're going to do 9 times 6, which is 54. We're going to record the 4, but we know that the 50 can be regrouped to become 5 whats? 5 tens. Okay. Next, we're going to move on to the tens place. We have 6 times 110, which is 6 tens. Good. Plus 5 more tens, which is 11 tens. So we're going to record one of those tens. Do you see how we're recording a 1 in the tens place to show that we're recording 110? But 10 of those tens can be regrouped to become 100. Now let's move on to the hundreds. We have 300s. So 6 copies of 300s is 1800s, but we're going to add one more that we regrouped to have 1900s. So do you see how our problem yields the same answer? Very good. So doing it side by side with the partial products method on the left and the standard algorithm on the right, the first step for both is thinking 8 times 3 is 24. But for the partial products way, I record 24 at the bottom. For the standard algorithm, I record the 4 only because I regrouped the 20 as two more tens. What's the next step I have to think about for the partial products way on the left? Sachi?
You have to do 7 times. No.
Is it really 7? 7 tens. Good. 7 tens times 8, which is 56 tens. How do I write 56 tens in standard algorithm? Evan?
560.
560. So for the partial products way, I will then record 560. What do I need to think about next for the standard algorithm? I already did. For both, I started by thinking about 3 times 8, right? What do I have to do next? Sornima?
You have to also think about 7 times.
I also have to think about 7 tens times 8, which is 56 tens. But I had 2 tens from above. So 56 tens, but if I add 2 more tens, how many tens do I have? 58 tens. So I will record the 8. And what do I do with the 50? 50 tens is the same as 500. So I'm going to write a little 5 to show that I have 5 extra hundreds that I have to add later. Now I'm working in the hundreds. What do I have to think about next for the partial products method? Sparsh? It's not 6 times 8. 600s times 8. If I make 8 copies of 600s, what do I get? I don't get 48. I get 48 hundreds. How do I write 48 hundreds in standard form? Varshini? 4,800. Good. Okay. Now with the standard algorithm, I also have to think 600s times 8 is 48 hundreds, but I have 5 from before. So what's 48 hundreds plus 5 more hundreds? Garrett? 53 hundreds. I'm going to record 53 hundreds. Now if I add up my partial products, I have 4 ones, 8 tens, 13 hundreds. I regroup 5 thousandths. So we get the same answer using the partial products method and the standard algorithm. They are exactly the same. We're thinking about the same partial products. We just have to add the regrouping in our heads. Through this process, we can see that the standard algorithm is really just the same as the partial products way, except instead of writing out each partial product, we're smushing them together and doing the regrouping at the same time. Make sense?